everyone, welcome to my YouTube channel. Today I'm solving Leetcode question 714. Best time to buy and sell stock with transaction fee. You are given an array prices where prices I is the price of a given stock on the ith day and an integer fee representing a transaction fee. Find the maximum profit you can achieve. You may complete as many transactions as you like, but you need to pay the transaction fee for each transaction. You may not engage in multiple transactions simultaneously. For example, that is, you must sell the stock before you buy it again. Example 1, price is 132849, fee is 2. The output is 8. The explanation is that maximum profit can be achieved by buy when the price is 1, sell when the price is 8, you gain profit of 7. You buy when the price is 4 and then sell when the price is 9, you gain profit of 5. So that's in total profit of 12. Then you need to deduct transaction fees from the total profit. So remember, in the problem statement, it says you need to pay the transaction fee for each transaction. But here, buy and sell one pair count as one transaction. That's from this example. We can understand, okay, if you perform a buy and then sell, this count as one transaction. So even though we kind of have 4 different transaction action, one buy, sell, 4 in total, but we just pay the transaction fee twice. So that's why it's 12 minus 4 instead of 12 minus 8. So that's something we need to pay attention to, and then that's something we understand from this example. So how to solve this one? It's very similar to the idea of solving the best time to buy and sell stock with cooldown. So in general, the idea for solving this one is still using the recursion with memoization. So recursion with memoization. So basically the idea for solving it is, let's say on each day, so on the ith day, let's just consider on ith day, what you can do. So basically you can choose there is no transaction, you just do nothing. And then in that case, you just carry out the current status and profit to the next day. Or you can choose to have a transaction. So what types of transaction? It's either purchase or buy, either purchase or sell, either buy or sell. But that it really depends on the status. Let's say if you hold a stock, then you can sell it. If you do not hold a stock, then you can purchase it. So you either buy a stock or sell a stock depending on whether or not you have a stock in hand at this day or at this moment. So basically there are 2 different scenarios, and what we need to determine is, okay, we need to get the maximum profit from the above 2 scenario, or from the above 2 options, either no transaction or perform a transaction. So in this case, let's construct our recursive function. So recursive function input. So you need to have I, so that denotes it's the ith day. And then another input is a status. This is a Boolean variable, indicates whether or not we hold a stock. So that will help us to determine what kind of transaction we can perform, whether it's sell stock or whether it's buy a stock. So that's the general idea for solving it. Let's start coding. So we mentioned that we want to use memoization. So the idea for memoization is you actually store the values you have previously calculated before. Let's say we're given this input I and hold. If you have already calculated before, then we just return a value instead of redoing the calculation from scratch. So that's the general idea. So in that case, we use a dictionary, we call it memory, to hold the values we calculated previously. And then we define our recursive function. I call it function. And then with the input I and the hold status. And then for any recursive function, we start with the base case. So that is if I is greater than or equal to the length of the prices. So basically list out of index. In that case, we return 0. And then we also check if we already calculated before. So that is if I hold in memory. In that case, we just return it without redo the calculation. And now we are start calling the recursion. So the first scenario, no transaction. So in that case, the profit is just the next day. Basically, you call the function for the next day, I plus 1, and then you carry out the same hold status to the next day. And then for the second scenario, if there is a transaction, so it's what type of transaction you can perform depending on your hold status. If you have a stock in hand, so if hold is true, in this case you can sell the stock. So in that case, the profit equals, when you sell a stock, you gain the price is I, and then we need to add the transaction fee into the equation, because this problem statement states that you need to pay the transaction fee for each transaction, and we also know that for buy and sell action, a pair, we only pay the transaction fee once. So in this case, let's assume that when we sell the stock, we just pay the transaction fee. So we need to minus the fee. And then after that, we move to the next day. After you sell a stock, this is the amount of money you gain, and then you need to deduct the transaction fee. And then after that, the hold status is become true. So after you sell the becomes false. So after you sell the stock, you no longer hold the stock. Else, so in this case, you are actually purchased the stock. So that is when you purchase stock, you reduce this price as I from your total profit right now. And then you also move to the next day. But in this case, since you just buy a stock, so in that case, the hold status is true. You are now holding one stock. Then the profit is actually the maximum between answer 1 and answer 2. So in that case, you just assign that to the memory. Memory I hold equals the maximum between the two scenarios, either transaction or no transaction. And then you just return the value you just calculated. Okay, now we just need to call our recursive function. We start with this day. The index is 0. The index of that day is 0. Basically, the first day. That's the 0 corresponding to the 0 index in this prices array. And then our hold status. When you start, you do not have any stock, so we start with hold status equals false. And then let's run our solution. Oh, I need to call return this function. So when I call recursive function, I need to return a value. Okay, it passed the initial test cases. Let me try submitting it. Okay, this solution is actually accepted, but the runtime and memory are not actually ideal. So in this case, I'm going to talk about how to optimize it a little bit. So usually we know that for the recursion with memoization, we can also solve it using the dynamic programming approach. So now I'm going to actually code the DP solution. So I'm going to code the dynamic programming approach. So, and then I'm actually going to do that by modifying my solution, previous solution, the recursion with memoization. So in that case, I'm using a array. So I need to remove memory. I'm using array. And then for this array, what I need to use here, so basically on each I state, I need to know I plus 1 state. So in that case, let me have this array for in range n plus 1. And then I need to have a hold status. So that's basically for this one in range 2. So let me start with this one, and then I will optimize the dynamic programming approach. So why this n plus 1? It's because every time for I, we need to know also I plus 1. So that's why this is our initial status, we n plus 1. And then our base case is just when the DP when we have the initial the case when it goes out of in the index, it's just 0. So we also already initialize with the 0. So we already cover our base case. So basically those two sections are already covered. So now we need to actually do the previously we were doing the recursion, but now we're just doing the calculation. So that is the answer. So basically for I in range n, that is we start with n minus 1, minus 1, minus 1. So, and then for hold in 0, 1. So now we start filling values to fill the values to this DP array. So still two scenarios. So answer 1 equals DP I plus 1 hold. Answer 2 is still the same if hold is true. If hold is 1, answer 2 equals the price is I minus fee plus DPI plus 1 false, which is 0. Else, if we do not hold the stock, in that case, our answer 2 equals minus price is I plus DPI plus 1, and then our held status becomes true. So after the calculation, we just return DP. After the calculation, basically DP I hold equals the maximum between answer 1 and then answer 2. So that's kind of how we calculate the values for DPI and the hold status. And then after the end, in the end, we just return DP 0, and then when the hold is 0. So that's our dynamic programming approach. So basically, I was referring to my previous solution, recursive solution with memoization, and then from there, it's very easy to code a dynamic programming solution. So now I'm going to delete my previous solution. Let me run this one. Oh, I forgot to define the n. N is the length of prices. Okay, I still have the list out of index arrow. Well, I start with the okay. So when I initialize that dp equals 0 for that in range n plus 1. And then when I start coding it, let's say -1, 0. When it's 0, it's 1, right? So oh, my bad. So why it is my bad? I think what I'm doing is here, actually I flipped the index. So here I should be in range 2, and then this one should be in range m plus 1. So let me try it again. Yeah, the mistake I made previously is I actually accidentally swapped the column index and row index. So when I initialize the DP array, so for simplicity purpose, I just change this one. So I only need to change one line. I do not have to change other lines when we call the cells inside the DP. So in that case, we pass the initial test cases. Let's try submit it. Okay, even though for this one, this is our dynamic programming solution. So let's try optimize this one a little bit. So right now for this solution, the time complexity is O(n), and then the space complexity is also O(n). So time complexity is also O(n). So can we optimize the space a little bit? Yes, we can. So if you look at this code, you would realize that, okay, every time we are actually, for each I, it's only depending on I plus 1. So in that case, we can actually change this, our DP, into we want to optimize this space complexity from O(n) to O(1). So in that case, when we initialize this DP, we actually want to initialize with 2 instead of n plus 1. So in that case, for I, our I is still in the same range. So here we just need to do some modification to this one. So every time we call the DPI, so we just actually mod 2 and then get the remainder from the mod 2. So that's kind of how we refer to that one. So basically every time we call DP and then we refer the index I inside the DP, we just like use that to mod 2. So and then calculate the remainder. So basically I divided to what is the remainder. So in that case, we'll only refer to two rows within this DP instead of n plus 1 rows. So in that case, let me submit the solution. First run it. Okay, it passed the initial test case. Let me try submit it. So compared with the previous solution, you can see that the memory is actually significantly optimized. So this is my solution for the Leetcode question 714. So I show you how I went from the recursion with memoization solution to a dynamic programming solution, and then after that, how I optimize the space complexity of this dynamic programming solution from O(n) to O(1). So the reason why I'm coding it this way instead of like just presenting an optimized dynamic programming solution at the very beginning is, for me, this recursion with memoization is most intuitive solution that it's very easy for me to come up with the right solution, especially during the interview. And then from there, if I refer to this solution, I can easily convert it to a dynamic programming approach. And then from there, I can just optimize the dynamic programming approach to optimize the space. So if you like my video, please feel free to subscribe my YouTube channel. And then for this best time to buy and sell stock, I actually have a playlist for that. You can see my other videos related to the buy and sell stock Leetcode questions. Thank you.